looking at the quadratic functions, I want to see the nature of the roots, the nature of the roots, the nature of the roots. Okay, nature of the roots. And what this one does, the nature of the root, is just for us to sketch the quadratic functions of the form ax squared plus bx plus c. It enables us to enable us to sketch to sketch a graph of the function ax squared plus bx plus c. Okay, and one thing you have to note is that you need to know, is your a positive or is it negative? If your a is in that quadratic expression, if your a is positive, if your a is positive, you're going to have this format of the shape, and if your a is negative, you're going to have a kappa shape. Okay. Case number one. Okay. Want to look at when a is greater than 0 and it's positive, and your discriminant is greater than 0. So what happened there? We're going to have this format. This is your y, this is your x. So we're going to have this. You can call this point here alpha, this point here beta. So this is your origin. So we have two real roots, two real roots. Okay. Then the next one, when your a is negative, okay, the discriminant is still the same thing. It's greater than 0. Then you have this cap shape, and this is your y, and this is your x, this is your origin. So you have what? Two real roots, two real roots. Okay, that's when your a is negative, discriminant is greater than 0. That's the nature of the curve. Then second one, a is greater than 0 and discriminant is equal to 0. Okay, that will give us two equal roots. Discriminant is greater than 0. Discriminant is equal to 0. Okay, we are going to have repeated roots. We're going to have repeated roots. It's going to be one repeated roots. So this is your y, and this is your x. This is your origin. So it's going to be this way. So this point is the repeater. So how real equal roots. Then when a is less 0, discriminant is also 0. So you have this. Okay. So in that case now, it's going to be this point. This is being repeated here. You're going to have this one. This is your y, and this is your x, this is your origin. So this is also real equal roots. Okay, and finally the third one, a is greater than 0. Discriminant is what? It is less 0. So this is why I could have no real roots. In that case, you have a complex number. So you have this format of the graph and no real roots. So the graph is not going to touch the x-axis. It's not going to touch the x-axis. So this is your origin. So no real roots. Then the next one is less 0, and then the discriminant is less than 0. Discriminant is less than 0. So in that case also, you have the same thing. The difference is just the curve. So this one also will not touch the x-axis. So these are the three natures of the roots that we have. A greater than 0, okay, we have, and discriminant is positive, it's greater than 0, we have 2 real roots, and then likewise for the other one. And then case 2, discriminant is equal to 0, is greater than 0, we have 2 real equal roots. Real equal roots. In that point, there's a point here repeated twice, and then to go like that. At that point, that is 20 points at that point. Okay, then same thing also here, and then when discriminant is less 0, so there won't be no real roots. Okay, so let's continue.